Hello, all my Training Tuesday friends. My name is Heidi Reese, and I am with the Dayton Superior and Simons Training Department. So let's first talk about a little housekeeping. We do this every time, so it should be nothing new. Everyone that has called in has been muted so that the webinar can be free of disruptions on the line. But don't let that deter you from answering any or asking any questions, chatting throughout, using the Zoom functionality, the chat functionality in Zoom, I should say. So at the very end, we'll have a question and answer session where I will go ahead and ask the questions that you put into chat, and we'll get them answered for you. In addition, all of our webinars are recorded and placed on Dayton Superior, both the YouTube channel as well as DaytonSuperior.com on the website. Just search for Training Tuesday and you'll find two links. One is to register for the next class, and then the other one is to see all of the past video recordings. All right, so just to let you know, this is for training purposes only. Anything that you might need as far as technical assistance will be on DaytonSuperior.com. Please feel free to contact customer service and your sales representative as well. So who is Dayton Superior? Let's talk a little bit about that. Hope all you guys know, but just to let you know, we are very holistic with the leading provider of engineered solutions for the concrete construction industry. We specialize in, as you know, accessories, chemicals, forming, and we have proven results through our Simons Forming shoring, as well as concrete repair and restoration, bridge deck, rebar splicing, precast, that we're going to be talking about in a little bit, and the tilt-up construction. So we have chemical solutions that are specifically formulated to meet designs. It's really a one-stop shop with us. In addition, I've mentioned we've got the engineering services as well as the training. So hopefully you're enjoying these Training Tuesdays, getting something out of them. But these are just introductory, half hour. If you need something more customized, please feel free to reach out to Chuck and myself through the training at DaytonSuperior.com. Again, that's training at DaytonSuperior.com. And just send us a quick email and we'll get back to you and discuss your needs. All right, so we're continuing with our precast month, and this topic today is insulated wall panels. We're going to be talking a little bit about the terms associated with the insulated wall panels, accessories to help build out the insulated wall panels, and we're going to talk about examples of projects, how to install them, physical characteristics, data, test reports, and the resources that are available to you. So with us today, we have two presenters. It's a treat. Is Keith Jensen. He's one of our technical services representatives for precast, as well as Salam Al-Robe. So Keith has a degree in chemical engineering from the University of California, Davies. He has worked on design, process, and sales engineering for the refining and chemical industries early in his career. Obviously, he's made it on over to us. The past 20 years, he has been in engineering and management roles for the architectural and structural wall panel producer industry. And let's talk about Salam a little bit. He's been working on insulated concrete products since 2015, and that's resulting in several research papers to help understand all of the mechanics, testing, and the structural liabilities of insulated wall panels. In addition to that, he is an associate member of the ACI 551 Tilt-Up Concrete Construction Committee and a member of the PCI Insulated Wall Panel Committee. He has a PhD in construction engineering from the University of Nebraska-Lincoln, and both his PhD dissertation as well as master's thesis are about the products that we're going to be talking about. And even one of his research was sponsored by the TCA titled Tilt-Up Partially Composite Insulated Wall Panels, the Gray Book. So with that, Keith, go ahead and get us started with the insulated sandwich panel construction.
All right, we'll see if I can make this slide move. Glossary of terms, a sandwich panel. The concrete is the bread in your sandwich, and the insulation is the meat or peanut butter and jelly or whatever you want in the middle. Keep in mind that the concrete is on the outside. As we move through here, let's see if I can make this go up again. Hey, Heidi, I'm not moving the slide. Can you move it for me? Are you with me still?
Whoever's moving the mouse, stop. I'm here. Stop moving the mouse, whoever. Okay.
Okay, that's me.
There you go. Okay, I've got it set. There you go.
All right. Well, what I just said, should have showed up the first time. So we've got the sandwiches, the outside, and the material that are held together by some means of mechanical connection. We call them Wythe connectors or shear connectors, panel ties, number of names. All right, Heidi, go move it up, Heidi. Here we're showing the structural Wythe, the fascial Wythe, and the insulation. This has changed a little bit recently in that we, go ahead and stop it, Heidi, you're rolling on too fast. Anyway, Wythe is a term that comes from the masonry industry. It's a layer of a unit layer of brick, but we've stolen that and called it a unit layer of concrete. Typically, insulated panels are called by their thicknesses. 222, 323, you can see them there, with the middle number being the, boy, Heidi, can you slow it down a little bit?
Yeah,
Maybe you want me to go
I'm not doing that. I'm not doing
okay,
that, so you must.
I don't know what's happened then. Anyway, let's go back. Like I said, let's see, it's just rolling on, Heidi. Is there anything I can do?
Take your mouse into the bottom left. You will see, you'll hover over the bottom left of the presentation.
Okay.
You see the back and forth arrow? See it there? There you go. You got it now. So you can go back and forth yourself. Fantastic. Thank you.
All right. Thank you. All right. Back where we should be. Structural Wythes. We call those backing Wythes and facing Wythes now a little bit more accurately if you're talking about composite panels, but Salam will cover those later in the presentation. As I mentioned, the structural Wythe, the panels are termed by their numbers, 222s, 322s. That's generally the layers of the things in order with the insulation in the middle. It says the structural Wythe is always said first. Not always. Different people will go different directions. But if you hear a 222, it's generally, like I said, referring to the concrete layers and the insulation layers. Moving on. Insulation is a key component. Number of different types of insulation. Extruded polystyrene R5 per inch. Polyisocyanurate, which is R6 to 8. If you believe the polyisocyanurate salesman, the other salesman will tell you it's less, but and the last is expanded polystyrene, also called EPS. The extruded is called XPS sometimes. It's very confusing because they're both X's, but the bottom line is all these insulations are a challenge to deal with. Let me go back to that. They're all difficult to cut. Different sandwich panel manufacturers will want you to melt them and cut them and do different kind of things with them in order to install their connectors. One thing there we talked about is the insulating value of the panels. It's R5. Concrete has an insulating value of about 0.07 per inch. It's 0.07, which is like 1/20. So it's a lot less. Thermal bridging is something where you have a gap in the insulation in the panel. And, you know, a lot of people don't think that a small gap is going to make a difference. It will, but it does. I'm sorry, I have to going back. This presentation is automatically running. I guess they want me to go faster. It seems like I speak fast enough already. Anyway, thermal bridging is important because if you have discontinuous insulation or steel pins, you can transfer a tremendous amount of heat. For instance, usually we used to think is like, hey, look, if I've got 80%, you know, R16 or 4 inches of insulation and only 20% of concrete, well, then I can just add that together and come out with like R10, since, you know, I've got mostly R16. That's not how it works. We use fluid dynamics to model heat flow, and these thermal bridges are like fire hoses for heat. They show up readily if you're using an infrared gun or something like that. You can see we've got a picture there of little dots on a panel. Those are condensation dots, but if you point an infrared gun, you can see a tremendous amount of heat. To whereas if you're using steel pins or have even minor discontinuities in your insulation, your R value can drop from your theoretical 16 to well less than half or a quarter of that. Heidi, can you move it up one now? I'm no longer having control. Now the Delta tie is Dayton Superior's tie. It's been around in the industry for a long, long time. One of the first there is, but it's non-metallic and non-thermally conductive. You can see here what it's geometrically configured to give you strong support between the Ys, and we use it to tie the panels together. Moving on, Heidi, let's move it up forward one. I've seemed to lost my ability to control here. Anyway, the benefits of the tie is that it doesn't thermal bridging, can maintain that thermal value of your panel. It can provide some composite action, but it's really best at connecting facing wise. Once again, it's also very good at connecting the panel wise with less ties than your typical pin. One of the other benefits here is that you don't have to do pre-drilled holes or melt anything or marking the insulation. It's very straightforward to install, as you'll see coming up on our next slides. You can see we've got one simple tie, endless applications. Comes in two sizes. One is our base one, very cost effective, a 5" by 7". It's good from insulation thicknesses between 2 and 4 inches. The second one, the XL, as you can see there, is 9 by 14 and can do insulation thicknesses up to 8 inches, which is about as thick as anybody uses in the industry. The orientation, that's all right, let's move to the orientation slide. The orientation slide shows basically the different orientations to install for different panel thicknesses. Basically, you want to make sure that you have more than 2 inches of the Delta tie engaged. That's very important to make sure that you get good engagement with your concrete. Here's an example of the Delta ties being installed. And you can see here that it's a very straightforward to install. These are just sheets of insulation with no machining or drilling or melting on them. They can just be installed, and it's one of the great benefits of the Delta tie. It's also, you can have a good visual indication if you've got a Delta tie installed correctly. Another nice feature of the Delta tie is that if you miss one, you can go back, cut a slot, and epoxy it in, which we all know when we have a pour go, have challenges, that going back to be able to fix things is a good thing, and that's one of the key benefits of Delta tie. Here we're precast here, but we'll make believe this is a picture of precast and not tilt up. They work about the same. When you're installing or manufacturing a wall panel, you start with putting your facing layer down or facing width. You put your insulation in there, get everything ready to go. And then you place the reinforcement, and then you basically pour your concrete. At that point, we move forward. You can install the insulation and the ties. Once again, we recommend for Delta ties, it's a very straightforward specification for installing. Now, this is mostly for installing facing wise when attached to a structural wipe. Salama later on will talk about composite action and different spacing like that. But we recommend 8 square foot per tie for any facing up to 4 inches thick, and it's a very straightforward thing. You can tell it depends on how wide your insulation sheets are, how often you put your Delta ties. You'll see the next slide shows you put them more often along the joint when you got wider sheets to maintain that 1 per 8 square feet. The spacing example here shows how many Delta ties you're going to use. You can see that compared to pins, you can use a lot less. Once again, this is for attaching a facing wipe to a structural wipe. And moving forward in a few moments, Salam will tell you a little bit about composite ties. I'm going to turn it over to him now, and hopefully he'll be able to control the screen better than I was. Salam, take it away.
Thank you.
I apologize, guys. I'm not sure why it's moving on its own. So, Salam, I'm going to go ahead and keep control. If that's okay, you just tell me next slide, okay?
Okay.
So we'll hit it. There we go.
Okay. First is define what is composite action. Composite action, these days people always refer to different, like using different equation to calculate the composite action. I think the BCI committee trying to define these term, so it will be easy to understand when there's a communication between the structural engineer and the manufacturer. Basically, it means that both these concrete layer will work together to resist the lateral load. As you know, the soil wall panel is either designed as non-composite, which means you assume almost or near zero composite action, or you assume some percent, which is called partially composite on soil wall panel. This percent composite is not a constant number. It's not like, I know some manufacturer telling people that their tie is 70% composite action or 80%. It doesn't depend only on the connector properties. It depends on the connector properties plus your load type, your length of the panel, and other parameter. But if you focus, can you go back? If you focus on only the connector, more short spacing will give you a higher composite. For example, this plots show you that the percent composite increased if you added more connector. But this is if we assumed panels have the same conditions, same load, same length, etc. And there's also, you need to keep in mind, there's like a different composite percent. For example, there's a percent composite for your stiffness, the stiffness of the panel. There's also a percent composite for your cracking moment. And there is a third one for nominal. These three, the BCI committee trying to define in the next standard, hopefully will come up soon. Now we're going to talk about the physical characteristic of delta tie. Back in 2004, when the delta tie was introduced, a large testing program has been done. 9 full-scale pre-stressed panel has been been tested. Was 36 feet long and 4 feet wide, using different spacing for the delta tie to understand the composite behavior of the global of your sandwich wall panel. In addition to these, the full-scale testing, small testing will also being done by the West Cheney laboratory. The small specimen, we got the tension test and the shear test. And then as you can see here, the tension test showed that the delta tie can hold up to 3,100 pounds. And for the shear is 3,200 pounds. As you can see in the plot, we used it was like different orientation for the 2-inch insulation. We used the lower value as an ultimate for the shear. Next. So in addition to the West Cheney testing program, Dayton Superior has been participating and for different study. This is study to help understanding the design of soil wall panel. Some of them has been done with the precast pre-stressed concrete institute, and some of them has been done with the tilt-up station. For example, the developing general methodology to understand the composition was done with the precast, and the last one, the tilt-up partial composite, has been done recently with different manufacturer. One of them is delta tie. In addition to this, Dayton Superior is also participating in currently like in different program. One of them is to understand the thermal bowing of the outside wall panel, and also to find out the standard testing for the tie, like with a precaution stud. Typical loading on non-composite panel. So this one is only for non-composite. It does not apply for a partial composite panel. Partial composite panel is a little bit complicated. We have the tool that can help you. At the end, I will go briefly on them. For non-composite, your load is either a tension force coming from lifting, or a suction force to the bed, or a wind suction force. Usually the tension for non-composite application, the tensile force is low. And you can see here with our maximum spacing, 8 square foot, can give you a safety factor 6 to 1. For the shear force is coming from the weight of your exterior weight, either if you supported exterior weight or not. Still, if we use the maximum spacing, the 8 square foot give you a safety factor 11 to 1. But just need to keep in mind, this one is just for non-composite application, not for the partial composite. For a partial composite, as I said, there's like a more complicated calculation. You need to run it through. We are happy to help with that. We have the spreadsheet that can do all this calculation to find out what is your spacing that you need for your partial composite, depend on your assumption for your percent composite. If you said, for example, 20%, you will need less connectors. If you want 50%, you will need more connectors, depending on your application. In addition to the waste chain report, we have the type past the ASTM E119. I think it was 5 inches structural wide, and for the NFPA 285 is we assume we use the 4-inch structural wide 422. Okay, so if you cast outside, if you're precaster, but it's sunny outside and you like to cast outside, and then suddenly it rain, you need to make sure that that rain will not go to your fresh concrete. As you know, the rain will add water, and water will increase the water to cement ratio. With that, will weaken the concrete strength and the connection. In addition to that, if you have a water removal operation to remove the water out of the insulation, as Keith mentioned, the delta tie is on the edges. So it's basically the delta tie hold the foam, but not like really hard. So you need to use another product if you're expecting rain, like we called it anti-flood, BFA. This plastic pin, you just punch it through the foam. You may need 3 to 4 per your insulation board, depend on your, I guess, how rough you're going to be with removing the water. Another product of Dayton Superior is Yeti Anchor. The Yeti Anchor is a bin type connector, similar. It is a GFRB connector. It also has the ASTM fire rating, 4-hour fire rating, and in addition to that, it also has the ICC report. The ICC report means that this tie has been tested, tension test and shear test, creep test, alkaline test, all the other testing to meet the ICC report. Yeti Anchor is similar to Delta tie. Both they have low thermal conductivity, so it's basically will reduce the thermal bridging. And also easy to use. you can use drill. I'll show later a short video. It has, can you go back? Thank you. So it has different length depend on your embedment depth. Usually is 1.5 to 2. The embedment depth depend on your concrete. If you, for example, if your exterior white is only 2 inches, you can use 1.5. If it is like 3 inches, you still have, you can use 2. With the increase of the embedment depth, you get increase in the capacity of the tie. They're also available for different insulation from 2 to 6 inches. Next. As Keith mentioned, the GFRP has low thermal conductivity. With that, it's helping reduce the thermal bridging and reducing the condensation. Both Delta tie and Yeti anchor are corrosion resistant since they are GFRP. And keep in mind, the GFRP right now has the ACI code. I think it's 440. So you can use that code to design your tie. And you can install them, as you can see in the picture. You can install them either vertical, which is for non-composite application, or a 45-degree, which is helping increasing the composite action of the tie. So if you used it 45, it will add, make it more structure efficient compared to non-composite. Next. Yeah, so one reason that Yeti anchor is best than the other competitor, first has a circular cross section. With that, it doesn't have like a weak axis compared to other competitor. For example, they have a rectangular shape. Sometimes when they installed, you missed the weak axis, and maybe you installed them in a weak axis, and that will reduce the capacity of the anchor itself. And also, because of this material strength of Yeti anchor, it has more shear capacity than the other competitor. With these more shear capacity, and it helps you reduce the spacing. For example, I think most of the competitors are using 16 inches spacing. And with Yeti, you can, for the same insulation thickness and the concrete width, you can use 24 inches. With that, will reduce the material cost and the labor cost 55%. Next. So for both Delta tie and Yeti, we have a layout service. It basically, if you send us the structural document for your building, we can send you Delta tie layout or Yeti, depending on our recommendation spacing. These mostly for non-composite. Also, we can help with the partially composite panel. For partially composite panel, we have a spreadsheet that can do both for tilt-up and precast. This spreadsheet is, they can do similar job to what program existing like Lackwall or Ericsson Wall. I know Ericsson Wall, Lackwall, they can do partial composite. This spreadsheet is similar capability, and as Heidi mentioned, has been working with this research since 2015. The beam spring model that Lackwall and Ericsson Wall has was part of my master's study. So we create a spreadsheet that can help with that and designing the partially composed panel for both precast and tilt-up. In addition to that, we also in addition to that, we also have a spreadsheet that can calculate the R value to your panel. The R value will depend if you, for example, if you assume there is a concrete breakout, concrete at the edges, or if you decided you want to use, we have another product, like we have Yeti and Delta tie, but we also have the other old product, the steel product, the welded wire girder and C-clip. I know we mentioned the thermal bridging coming from welded wire. Some engineers still using the welded wire girder, and with that we can help calculate the R value, the reduction in R value because due to using a welded wire girder or cycle. And in addition to that, we have online tool that can help. This one is only for non-composite. It is not for the partial composite. If you have any question for partial composite, you can reach to us. This one is, as I said, non-composite. Basically, you choose the product is either a Yeti anchor or a delta tie, and depend on the exterior wire thickness, so wind will space the anchor according to that, and this will give you a factor 4:1. And if you would like to, just go to DaytonSuperior.com and search for sandwich calculator. Make sure you're not hungry. Otherwise, you're gonna go to somebody
You don't
else.
like my search terms? I thought it was catchy.
Okay. I mean, if someone types sandwich, well, anyway. So a job site so this job site has, I think it is done in British Columbia with one of the tilt-up contractor using Yeti anchor. Yeti anchor also has been used with many precaster. For this, Yeti anchor is easy to use. It's not like you don't. First of all, there's two methods to use. Is either you drill using a drill with a half-inch socket, hexagon socket. It's easy to. You don't need to push hard. Once you start drilling, will go through the insulation. With that, it will help speeding up the process. Or if you prefer, you can pre-drill a hole in the foam. And then once you have all the hole in your foam layer, you can just wedge them through. As you can see in this video, yep, it's working. So, one guy can do the job really easily. Maybe you're gonna need a multiple person if you have like a big panel. But overall, is easy to use and does not require a lot of working.
Fantastic. Thank you, Salam. So we're a little over time. If you guys have any questions, please go ahead and put them in chat right now. We have a little bit of time while I go through these slides. You guys know that we have resources out on DaytonSuperior.com, such as product pages, tech data sheets, engineering handouts, all the stuff that Salam just went over, as well as training and contact information. We have websites there. I mentioned training at DaytonSuperior.com. But I also want to mention really quick, because February is precast deals. That's why we're doing a lot of these, and specifically around the delta ties and the Yeti anchors that we've talked about. In addition, we have all of the P110, P75, 75R, 76, and P140s on special, so contact your sales representative for that. Then guess what? We are going to the precast show. A lot of our people are already there on the way. I believe it starts tomorrow. Nope, the 23rd, excuse me. And we are in booth 243, so come check it out. Is there any questions?
I also
I keep pushing.
will be there
Oh,
if someone have a question about anything about the person composite action.
Yes, questions on anything that we've gone over. We do also have a training promotion going on right now. You see that on your screen, so you can sign up for that. Contact me if you like, and just take one of those and you get one-time promotional savings on select accessory products when a sales representative does that for you. And of course, I always want to know your thoughts, so you let me know that. So, hi, Isabel. Yeah, Isabel, we don't get out our presentations. However, we can get you set up with any of the people that I spoke today, as well as Chuck Hook, our National Training Manager, and we can go over things to better customize for what you want. If you're precast or tilt, we also have a TiltWorks application. We can get you set up with that team as well. Anything else? Okay, again, sorry for all of the craziness. I think the presentation had a mind of its own. Poor Keith and Salam, it just kept on going. I wanted you to go faster. So everybody on the phone, I appreciate you. I appreciate you guys, Keith and Salam, for taking time out and letting us know all the information. And I will talk to you next Tuesday, guys. Thanks, and have a great Tuesday.
Bye now.
Bye-bye.